Monthly Space News. We're going to talk a lot about moon missions. These are the unmanned moon missions. There were two of them launched since the last meeting. A little bit of history on that. There have been a lot of successful robotic landings on the moon that were soft landings, not even counting the ones that were hard landings, meaning crashes accidentally or in a few cases on purpose to see what would happen blowing ice out there. The history of this was there's only been three countries so far that have made successful robotic soft landings. The first was actually Russia. In fact, they were also the first to even hit the moon. They had a variety of landings and rovers, for that matter, going out between 1966, the first one, all the way out through 1976. And they included rovers and some sample return missions. Following them very closely was the US. We ran a few of these automated landings. We never did a rover, actually. It was just a difference in policy because, after all, we had the humans coming with their own fancy cars. They had a really good rover. So we really stopped pretty much in 1968. We have not done anything robotically on the surface of the moon since then. Then China joined the race starting in 2013. They've had a total of three missions, including rovers and including going to the far side of the moon, which nobody else had really done, certainly not with a rover. More recently, there have been some robotic moon landing attempts. They failed. Israel tried one in 2019. India made an attempt in 2019. The orbiter for that is still up there, but the lander itself failed. It crashed. And then Japan, just this year, we reviewed this one, the Hokuto R mission. That one had rovers in it from the United Arab Emirates and from Japan. And that one failed due to reasons we talked about in one of our earlier meetings. So, what are the new ones? Well, both India and Russia are launching missions and just did launch them, actually. India launched on July 14th, Russia on August 10th, and they're arriving within 2 days of each other, August 23rd and August 21st. They're pretty similar in a lot of ways. They're both landing, starting from a circular orbit 100 kilometers above the moon in a polar lunar orbit. And the difference, though, is that no one has ever landed anything this close to the South Pole, which, of course, is quite strategic because everybody believes that there is quite a bit of water there hidden in the dark areas of craters there. And if we're going to exploit the resources of the moon, that's the obvious first place to start. The water's there. From that, you can make oxygen, rocket fuel, and so on. Another distinction here compared to the Japanese recent mission is that these landers do have multiple ways of sensing altitude. They have lasers and radar and even image processing, all these things. So they're not going to have the problem of a single point of failure, that if they ever either have an actual failure of one of these sensors, or even if they think it's failed, they won't be at the mercy of inertial guidance, which very quickly goes quite bad. And that's actually what ended up killing the Japanese mission. So first we'll talk about India's Chandrayaan-3 lunar lander and rover. This picture on the right is from one of their brochures describing it. So they have a rocket, their heaviest lift rocket, that gets them up to Earth orbit. They have a propulsion module, which you can see on the right-hand side of this picture. It will actually then carry that to the moon into lunar orbit. And then from there, the lander will separate and go on down. The lander itself carries a rover. The propulsion module will stay up as a communications relay. In fact, a lot of that is really being handled by their previous orbiter as well. And then, of course, there's the lander and the rover, as shown in these parts here. A little more detail on their lander and rover. First of all, it's solar powered. It's only going to operate for one lunar day. It's very difficult because the lunar nights are so long. It's very difficult to survive that unless you have a radioisotope generating mechanism of some sort to provide you with the heat to survive the night. So they're basically just whatever is left of the lunar day, which is 14 Earth days, that's what they're going to do, and then it'll probably die after that. It does have a variety of scientific instruments. Of course, they're looking for resources like water and trying to analyze the soil, looking for background radiation, all those kinds of things. It weighs almost 4,000 pounds. It's fairly hefty. The rover itself is about 57 pounds. And you can see that in this picture. A couple of things I'll point out here. One is, notice the solar cells here are vertical. Because you're planning on landing near the pole, you think about the way the Earth orbits the sun, that defines a plane. The moon is orbiting in that same plane, and the axis is perpendicular to that. So if you're at the pole, any rays of sun that you get, you're going to get coming in pretty much horizontally. So it's very different than a typical other rover situation oriented toward the middle latitudes, which is where things have been previously. The rover itself is shown in this picture. You can see it has 6 wheels. Really only 4 of them are that obvious, but there's 6 there. The solar array actually flips up because it too has to get its power pretty much in a vertical position. They're showing a landing ramp here. This must be trying to demonstrate an extreme position because it looks like the ramp is setting down quite a bit lower than the level of the struts supporting the whole thing. So maybe they're showing a worst case or something in this case. A little more details on the rover. Here you can see more clearly the six wheels and the flip-up solar panel. This is not an unusual problem. This picture is taken in Fairbanks, Alaska. If you want solar power up there, you're getting close to the Arctic Circle. You're not quite there yet. But you also pretty much go for vertical solar arrays. This house has them all over the place. On top of the roof and the sides, you can see some, and even around this little shed, I think that's some additional solar cells. Now, the orbits, it's taking a much longer time to get there than any human mission would because you're not constricted to, having life support. So they can do it more efficiently. It doesn't take them as much fuel to do it. What they do is they get off the Earth, just boosted up by their main rocket. And then every time you do an orbit, when you're at the point closest to Earth, you fire the engines and it takes you to a higher orbit. You can see the series of them here each time it fires. It turns out that's a much more fuel efficient way of raising your altitudes. Anyway, at some point they decide they're high enough, they do a transfer orbit, they go to the moon, and then they kind of do the same kind of thing. They're starting off in a pretty high elliptical orbit, then they go down, gradually firing so that they decrease their orbital height, and eventually they're at 100 kilometers in a circular orbit. At that point, then they drop down to the lunar South Pole. And currently, as of August 9th anyway, they were at an orbit somewhere in the middle in this picture here, 174 kilometers by 1437 kilometers, still an elliptical orbit. Now, the Russian rover, a little bit different. First of all, there's no rover, it's just a lander. The thing weighs about 1,750 pounds. This one has solar power, of course, and again, the vertical cells. But this one has a radioisotope thermal generator that just happens to be plutonium based. So as a result, they get constant source of heat even through the lunar night. So they survive. They're planning on operating at least a year. They'll probably get more than a year out of it, but that's their design goal is 1 year. Usually these things are quite conservative. Most of those things that we put up on Mars, they were designed to last a year, and 10 years later, they're still going. This has a variety of scientific instruments as well, pretty similar in a lot of ways to the Indian one. One additional thing, though, it does have a robot arm for soil samples, and you can see that on the right-hand side here, right in dead center of the front of this, that's where the robotic arm is, and it has several hinge joints, so it can reach out. It can go down something like 25 centimeters and big. It's kind of hard to tell what most of this stuff is. You have the solar panels that are blue here. There's some cameras up on top on the extreme left and right. There's a variety of remote sensing instruments that are exposed in this. Now, this, of course, is sort of a mock-up. The actual thing, the way it looks, is more like it looks down at the bottom of the screen here. Everything ends up getting covered in gold foil. It's not just foil, it's insulated bags. Think of freezer bags. You're pretty much doing that, trying to stabilize the temperature. So when it gets super hot during the day, it doesn't get as hot. And when it's getting super cold at night, it doesn't get as cold. That was also true for the Indian one as well. If you look at theirs, everything gets coated both on the rover and on the lander to try to stabilize temperatures as much as possible. This is the rocket that launched it, Soyuz 21B. That's their most powerful heavy lift rocket. That was actually a picture of that launch. Frigate is just the name of the upper stage. That's what they always use. There's other things going on related to things like getting power on the moon by solar cells or nuclear. NASA has a variety of programs for helping smaller companies develop innovative technologies. They give out a lot of awards for this. There's one called Tipping Point Awards. By awards, I mean grants of money. They contract to do specific tasks. In this particular case, Astrobotic just got a new contract for proving out a solar grid. And what they're doing is they're going to spool out a 1 kilometer long, a high voltage cable between solar arrays and a rover. So what will happen is the rover would start from a lander. It will actually carry out its kilometer of cable, demonstrating feasibility, actually doing it on the surface of the moon. And it turns out it's not a trivial problem. You want to transmit power at very high voltages. Of course, the solar cells don't have that high a voltage. So in fact, they have to convert it to AC and step it up to high voltages AC. Maybe they transmit it in DC form, maybe they don't, I'm not sure which, and then ultimately get back to power levels that are needed out at devices like a rover or anything else. But the idea is start to build a power grid. Now, we mentioned that the South Pole is strategic. It's not really just for materials. The South Pole is also strategic because from the South Pole, you can get solar power fairly easily if you just stick them up on top of a tower or on top of a mountain. You can actually get power most of the time because you're so close to the pole, you're not really in a shadowed region if you simply elevate the solar cells enough. So Astrobotic also has a separate project that's already funded for putting in these vertical solar arrays up on top of towers. They're basically trying to work out a whole solution for getting power on the moon. In this case, it's just solar. To survive the night, you still need something like radioisotope generators or reactor. One way or another, to get a lot of power, you're going to have to go nuclear. But some of the other tipping point funding has been for a radioisotope power system. But most of these in the past, they just use thermocouples essentially. They basically have a heat source, which is the radioisotope. It heats up a thermocouple and generates current. That's not all that efficient. They're actually proposing building a Stirling engine, a particular type of engine, which will use that heat much more efficiently. Blue Origin had already, on their own, demonstrated producing solar cells with lunar materials, and now they have some grant money to do that, funded by NASA. And there are a variety of other projects awarded as tipping point, but they're outside of this power area. Okay, on a separate topic. We talked before about the race to orbit for methalox rockets. And methalox means propellants are methane, liquid methane, and liquid oxygen. And that includes LNG, liquefied natural gas, which is mostly methane. There are a lot of companies doing that. We'll highlight that in the next slide. But the one that won is Chinese. It's a nominally private company called Landspace. In reality, almost all private companies are still pretty heavily really regulated and managed by the government, but they do allow a certain aspect of, I guess, rewards for the founders of this. So anyway, this particular one did achieve orbit. They had tried before, we reported that last time, and the booster had worked, but the second stage failed. Well, this time it worked. Now, what is the size of this thing? Well, the future payload for this is listed as 6,000 kilograms, which is 13,000 pounds, or to low Earth orbit, or 4,000 kilograms to a little higher orbit. That's polar as well, which takes a little bit more fuel to get to. Now, if you want to compare that to other rockets, well, if you're trying to compare it to the kind of the gold standard right now, which is the Falcon 9, that Falcon 9, that's not powered by methane, but it is the biggest seller in the market. The thing is, the Falcon 9 has reusable boosters. They do intend to do that for this particular rocket, but they haven't done it yet. They've tested out reigniting the engines, which they need to do for reusability, but they haven't really done much else with it as far as I can tell. The bottom line is that it only carries about a third the payload that the Falcon 9 carries. So it's quite a bit smaller rocket. Physically, it's not that different. I put up a variety of the other rockets here that are in the race, or that were in the race to be the first. And they are the Terran 1, the Neutron rocket from Rocket Lab. This is the ZK2, often just spelled out as ZQ2. This is the Vulcan rocket, which is coming soon. And this is the Terran R. The Falcon 9 is kind of in between these two, in between the Vulcan and the Neutron. And then, of course, you have the really big ones coming, the one from Blue Origin and Starship. So in terms of orbital attempt failures, there were really just two. That was the last ZQ one back in December, and then the Relativity Space one in March. That failed. And not only did it fail, but they decided that wasn't really a market worth pursuing. It was too small of a rocket. So they've abandoned that anyway, and that's why they're working on this Terran R. But that won't be available until 2026. So we're not going to see them for a while. So the ones that are still in the race then are SpaceX with Starship. Maybe it'll go in 2023, maybe not. United Launch Alliance has the Vulcan. And that's another one where they're still thinking maybe they can get it off in the fourth quarter, but seems unlikely. They have had problems with the engines, which are from Blue Origin. But they may get up there in 2023. Blue Origin itself, they will get the New Glenn going maybe in 2024. The Rocket Lab Neutron, maybe 2024. All these things you have to take with a grain of salt, but at least they're the ones that are in the race for second place. The Euclid Space Telescope, we talked about that one, was launched just last time, and we covered that. Its idea is to map a third of the universe, basically looking back over about 10 billion years, trying to map where the dark matter and dark energy effects are to help understand it, because as we pointed out, fundamentally, nobody really understands it. The commissioning is going well. All the systems are functioning. They've seen first light, meaning they got some pictures, and there's an example of that in the lower left corner here. This is a large starfield area to the very left, and then the little square highlights a detail view. So at least, they are getting actual starlight. There's still a lot of calibration and performance verification to go on, at least another 8 weeks of that. But it's well on its way. Everything is really working pretty much as it should. So people are pretty happy about this one. Okay, another really minor one here. Virgin Galactic did their second commercial flight. We had just reported on their first one previously, but their passengers were really the Italian government, the Air Force, and a research person. This one actually had honest to goodness private tourists from somewhere in the Caribbean. And this means a suborbital flight. They get up to about 55 miles. That's actually a few miles higher than the last run. And they still get about 3 minutes of weightlessness. So this is the one that's really a space plane that just goes, doesn't complete an entire orbit, just goes up and gives them a few minutes in space. Okay, now we're at to the point where we let people guess how many launches have there been since the last meeting, which was July 8th. And the picture shown here is that ZQ-2 launch. This is the one that came out of China from the nominally private company there. Anybody want to take any guesses? Okay, I couldn't hear any. But anyway, okay, the answer is 25. It's actually quite a few.
25.
Okay, so we've already talked about some of these. Of course, as usual, there's plenty of Starlink satellites going up. The last round of the original version of these satellites has now been sent up. Now they're all going to be these version 2 minis. The full version 2s were the ones that were going to be launched on Starship, but Starship isn't there yet. So they have a scaled back version. But even that scaled back version is about 4 times the size of the original satellite. So they're quite a bit bigger. And of course, they've been launching quite a few of those. I'll highlight this Electron launch on July 17th, putting up small satellites. They finally have managed to recover a booster. They've tried before catching them with helicopters in a big net, and that wasn't working out all that well. They finally decided they can just drop them in the ocean and recover them that way. So at least they recovered it. They haven't yet flown with any kind of recovered craft. They have an engine that they recovered earlier that they will be using this year. That'll be their first test, and then presumably they'll refurbish this booster as well. They need to get their costs down, and this should be a good way to do it if they can make it work. They've been trying for a while. Typically, a lot of Chinese launches and a lot of Falcon 9 launches of Starlink satellites. One notable one is that the heaviest geosynchronous satellite, the high altitude comm satellites that went up, the heaviest one ever was launched, and that was on a Falcon Heavy. It weighed 9.2 metric tons, so 9,200 kilograms. Let's see. The Antares rocket that went up on August 1st, that was taking cargo to the International Space Station. And of course, they've done that before. What was notable about this was this is the very last one of the series where they were using the first stage that was actually built in Ukraine using a Russian engine. Using a Russian engine is a no-no, and of course, you can't really get things built in Ukraine right now. So they're working with Firefly to build the first stage for them, including the Firefly engines. So that won't be coming for another year or so, but at least it's in progress. This was the last of the old generation. Other than that, yeah, pretty routine kind of stuff, a variety of communication satellites. A lot of the Chinese launches, you can't really tell what they are. They don't really advertise that much. They'll say general things like Earth observation satellites or something. That's pretty much it. Any other questions or comments? Okay, any other comments? Or it's time to turn it over to our main speaker then. Other space-related videos or slide presentations by me are available at the link shown here. That includes a web page and also a list of videos at my YouTube channel, so you can view them or subscribe for notifications about future videos. These presentations are mostly made as part of the meetings of National Space Society's North Houston chapter, and a link to that is shown. Topics like these are presented as part of a monthly news segment, and there are also lots of other interesting speakers and open discussions. You can attend in person or online via Zoom. Come join us.